UWL is interested in the relationship between anxiety level and the need to succeed in school. A sample of 400 students took a test that measured both their anxiety level and their need to succeed, and we want to know if need to succeed has an effect on anxiety level. We want to test this at the 1% level. So our sample of 400 people were split into one of 9 different categories based on either high, medium, or low need and high, medium, or low anxiety. And what we want to do is find out if there's a relationship between these variables. So this is a test of independence, and when you're doing a test of independence, your null hypothesis is that the two variables are independent of one another, with an alternative hypothesis that they are dependent of one another. Now, in order to get our test statistic to find out if these variables are independent or not, we need to get our row totals and column totals in our table because they have not been provided for us. So for the first column, high anxiety, you would just add up 56, 42, and 7, and you would get a total of 105. And you'll do this for the other columns, and you'll also do that for the rows. So for high need, 56, 79, and 20 give you a total of 155. So I will include the rest of these totals here for you. Now that we have all our row and column totals, we can start finding our expected counts. For the first category, high need, high anxiety, we have a column total and row total of 155 and 105. So we multiply those. We divide by our total sample size of 400 to get an expected count of 40.688. For the next group, we have a total of 200 and a 155 if we move left to right in the table, divided by our 400, which gives an expected count of 77.5. So we continue this through all of the 9 categories and find all of our E's, and I'll add those to the table now. Now that we have all our expected counts, we can get our test statistic, chi-squared, which takes the observed count, O, minus the expected count that I've added to the table. You square that, and then you divide by your E. And you do that for every cell, and you add them all up. So you'll have 9 terms here. I'm not going to write them all, and I'll write a few of them. Notice if you do look in the table that all of those values I added in red, all those E's, are greater than 5, so the conditions required for the test to be valid are satisfied. And for this, what you should get is a test statistic of 35.694. Degrees of freedom for our chi-squared for a test of independence is row total minus 1, or number of rows minus 1, times number of columns minus 1. So we have 3 for each of these. So we'll get degrees of freedom 4. So we want to look for our test statistic in row 4 of our chi-square table. And in looking for 35.694, what we're going to find is that it is all the way off the chart. So it's much larger than our largest value, which is 18.47. That tells us, since it's farther out in the tail, that the tail area beyond it is going to be smaller than what we have here of 0.001. So our p-value is less than 0.001. So we have the smallest possible p-value from the table, which will be less than our significance level that we were told to use of 1%. And so we're going to reject the null. And so when we reject the null, what we're going to find is that our two variables are dependent on one another. So here we have significant evidence that need to succeed and anxiety level are dependent.